Recently, scientists think they've created what for 80 years was just a theoretical material. And that is the really rather weird substance of metallic hydrogen. What is this form of hydrogen? How is it created? And what makes it actually so special? Well, metals share some fairly standard properties. They're generally shiny and good conductors of heat and electricity. These properties are normally due to metals being held together by quite strong bonds, requiring lots of heat to make them boil, whilst at the same time loose electrons in their structure allow those electrons to be passed through the structure as electricity. So hydrogen, which is normally a very light gas, how does that actually come to exhibit some of these properties, or even anything like these properties? Well, it isn't going to happen naturally on Earth, but there are certain circumstances within some cool stars or gas giants where this might happen. However, these conditions are so extreme it's difficult for scientists to recreate them here on Earth. So this requires both very low temperatures and extremely high pressures. The temperature used in the recent experiment to create metallic hydrogen was 5.5 degrees Kelvin, or 5.5 degrees above absolute zero. Or to put that in perspective, about 25 degrees colder than the surface of Pluto. However, it's the actual pressure which is really extreme. The pressure on the surface of the Earth is normally a little over 1000 millibars. The pressure needed to create metallic hydrogen is nearly 5 million times greater than this. These conditions do mean that it's unlikely we're going to be able to mass produce metallic hydrogen. Why would we want to? Well, as hydrogen's crushed together under this enormous pressure, of course try to take up as small a space as possible. Now, hydrogen, normally when it's a gas, isn't kind of free atoms of hydrogen floating about. Instead, each hydrogen atom pairs up with another hydrogen atom. It's bonded together in a relatively stable structure. These paired atoms, when under pressure, will then sort themselves out into a loose, cube-like formation. As the pressure builds, these atoms are pushed closer and closer and closer together, where hydrogen becomes solid, but it's still transparent. The gaps between the pairs of hydrogen atoms still allow light to pass through it. Also, this gap means that heat and electricity won't actually pass along the material. This means that transparent hydrogen is an insulator. As you crush the hydrogen still more, the gap between the atoms disappears and light can no longer pass through the material. It also means that under some circumstances electricity can be passed from one atom to the other, making this form of hydrogen a semiconductor. Now, finally, when you increase the pressure still more, hydrogen gets really weird. Here the bonds which are pairing up the hydrogen atom actually break down, enabling the new cube alignment of the atoms to take up actually far less room than before. This bond with the other hydrogen atom meant that they each shared an electron, making up a complete stable electron shell of 2 electrons for the combined structure. With this bond broken, each hydrogen atom now has only 1 electron in its outer shell. So to push extra electrons, they will flow very easily along the structure in what's known as a superconductor. At the same time, the structure now also reflects light back from the shiny surface of the material. Now, currently, tests are still being conducted on the hydrogen at extreme pressures, but scientists believe that when the pressure is actually released, the hydrogen will still retain its metallic state. If it does, there may be some practical applications of this technology, but they're going to be on the small scale and extremely specialized unless we can find another method of either creating or collecting metallic hydrogen.